Water. It was a bad night. Well, actually, the whole day's been pretty good. We got to spend it with Debbie. Got to go to getting stuff prepped this morning to go to dinner with her mother. We got there and forgot the doggone. I know Brad Stein hates casserole, but it was a sweet potato slash winter squash, butternut squash casserole mix. And this time, instead of using walnuts, Debbie used pecans, or as they say in the South or in the North, pecans, and made a little glaze for the top. This old boy had a good time with that. Well, anyway, we had dinner, and, I coughed a little here and there, but not that much. Started getting tired at the end of the day, which I do. Sleeping down here in the chair, I always lose 1 to 2 hours a night minimum. And it was just up there. Debbie read Psalm 81, and all of a sudden rolled over, and it started kicking in. Cough so that it hurt. Anyway, that just explains the way I sound, the way I'm going to snort, etc., etc. What's the talk on? Oliver and White, their closed center system. Not closed center load sensing, not, what do they call it? Oh, PFC. It's not a pressure flow compensated system. Now, strangely enough, pressure flow compensated and actual load sensing systems are two different animals that work similar. I'll explain later. No, Oliver's was strictly a pressure compensated system. That's it. Now, what is pressure compensation? Well, it's a fancy term where you have a pump that's variable flow, and you have a system with a set pressure. And the pressure is in the compensator. Essentially, it's a relief valve. Only rather than pouring back the tank, when it pops, oil goes to a piston and de-strokes your pump, puts it to neutral, or close to neutral. Now, in excavators and such, they have an unloader because they'll put it near neutral. But if you have a 100-gallon pump, they'll drop it down so it's someplace around 8 gallons a minute, a little less than 10%, somewhere between 5 and 10%. They'll put it down there for two purposes. One of them is to keep the system semi-pressurized so that there is, standby pressure there sufficient enough, A, to operate the pump, but also B, to, to have the system primed in a sense. So that makes a difference. That's on both your PFC systems and your load sensing. The load sensing systems have unloaders. PFC systems generally don't. They just have leakage built into their system, and it has two valves. So load sensing is a whole nother animal. But in agriculture, many tractors have a PFC, pressure flow compensating system. And it is what it says. The pressure and flow are compensated. Pressure changes the flow rate, but it also has standby, so that both pressure and flow are turned down. And in your regular pressure compensated system, so it's 3 separate systems here, all closed center, meaning that when the valve goes to neutral, that's it, it's deadheaded. And all of them are variable pumps, but they have different controls, similar but different. Starts out with your pressure compensated system like your simple Whites do, up to about probably the 2155. No, maybe not that one. I haven't worked on many of those. But the 2135 and 2155 have PFC systems in them. Or do they? No, they don't. They have just plain pressure compensated systems, but they have a charge pump. Different. Forget about that for now. So we can talk right on up to the 2155s. But the simpler systems are on the 1750s, 1850s, or no, not the 1755, 1855, 1955, two 180s. What's the other one there? 2255. I'm not sure about the 2050s and the 2250s, but these others, the whites, 2105s, 285s, 288s, 2110s, and as well as the 2180s and around there, 2135s and such, have just a pressure compensated system. And what is that? Well, the pump wants a pressure, so the flow changes to try and maintain that pressure. In neutral, when you start the tractor up, there's an unloader. That is correct. But the unloader is wide open. And the idea of the unloader is you turn the key off, and every once in a while you hear a click. That's the unloader snapping open. And what is the unloader? When you shut the system off, the pressure comes down, it pops open. You start cranking the tractor, the pump's at full stroke. There's no pressure. So there's no pressure compensation. Oil just flows right through into the tank. Well, then it speeds up. Gets to a particular flow rate going through an orifice. Dink! Shuts that thing off tighter than tight. It might have a slight leak, but you know what I mean. That's a starting unloader. That's its only purpose, is starting. As soon as that shuts off, then the pump starts building pressure, and you'll hear it. And it'll come up, and it shouldn't be too loud, but you'll hear something. And it'll go to neutral. Why? The pressure compensator pops just like a relief valve, but it doesn't go to tank. Like I said, it goes into the piston, and then the pump comes down minimum stroke, I'll say. 0, but not quite. Now, in these systems on the Olivers and such, they'll probably get down to maybe a few tenths of a gallon a minute. Possibly half a gallon with a lot of leak. When they have a serious amount of leak, let me tell you, you'll know it's bad. There's 3 lines on a pressure compensated pump external. Now, your compensator can be remote, but on all these, it's all mounted on the pump. There's 3 lines. One is your inlet, the other is your outlet, and the third is a drain line, a little bitty one on top. It goes right back to your reservoir. Why? Well, they're counting on the pump having some slippage or internal leakage. They want it to. You have fresh oil going through the pump all the time. If the pump's running hot, that oil's running out and into the reservoir. You say, well, that's not going through a cooler. No, it's not, but they have a cooler pump on these things. So it takes care of that problem. Some parts, if I remember right, of the charge pump system sent cooling oil through. The charge pump was much bigger than the pump itself as far as flow rate. And it's in the same position on the charge pump systems on the bigger tractors. It's in the same position as the cooler pump on the small tractors. Inside, right there in front of the drive system, between the drive system and the main pump, hydraulic pump. So now that we've got that established, you got oil in, oil out, oil leakage, and you have a pressure compensator just running this system. Now on the outlet side, like I told you, one of the first things is the unloader. When everything is off, it's open. So then it closes, the whole system's deadheaded. Dink, that's it. Why? Because the valves are closed. All the valves are closed. Your 3-point hitch, your 2 or 3 remotes, depending on how many you have, it's all off. You have a little bit running through your low pressure system. Steering and low pressure. That's a whole nother deal. So when you fire it up, the unloader goes dink, closes, minimum stroke. Now in the valve body, you have your priority pressure valve for your steering. You have a low pressure valve for your brakes and PTO. And what's the other? Oh, and your relief valve. Now I've said it before on some other stuff, and I'll say it again. 300 psi is a minimum difference that you want your relief valve. If there's any other valve other than, or any other control in the system other than the relief valve, like this pressure compensator, it's generally set 23 to 2,500 pounds of pressure. Well, that means your relief valve has to be 300 pounds above whatever your pressure setting is here on your compensator. Compensator's 2,500, you need to be minimum of 2,800 on your relief. Why? Because as that pump moves back and forth and comes up to a peak and spikes every so often, that relief's going to crack. as it should. But if it cracks too often, you've got heat. You just need your pump to shut off. So every time that sucker cracks and the higher the pressure, more trouble, more heat. That's one of the things with the systems. Now, as far as your priority valve for steering, there's an interesting side to this. They got a whole huge test procedure for a lot of this. Oliver has a huge test procedure for leakage and a lot of this stuff. And I never had to do any of that. Ever. If you test the system, it generally works. And you find by the time the customer calls you, you find a problem. You know the problem's there and what you have to do to fix it. You don't need to go through all the leakage tests like they have. So, but still, let's go through the basics now. You put on a new pump. You got a new compensator. You got to figure out what your system is. Most compensators have a seal. Sorry, buddy, you're going to have to break the seal. You're going to fire your tractor up with a gauge in your remotes. Let the thing do its spinning and moving around. You want a hose in one set of remotes, and the other remote you want your pressure gauge. Why? Well, when you got your pressure compensator up there, everything's in there, you're going to bleed the system because they do have bleeders in these things. Specifically on the filter head, which takes a long time. It's a big filter, but it's a fine filter and deep. So once that's all bled out, you fire your pump up, you get it running. Now you filled the pump body with oil, correct? You do. Take that fitting off the top, put a little bit of a hose in there, and just pour oil in there until it comes back out. You need that body full of oil. That's your only lubrication until it draws oil through the pistons. Trust me on that. So you changed your pump, you took the seal off your compensator, and I'll tell you why in a minute. You got it bled out, and you fire the tractor up, you've got your loop hose, everything sounds normal. You're going to hear a little snarking and knocking and for a bit, and then it'll settle down. You're going to grab the lever, just above idle, 1100, 1200 RPM. You're going to grab your lever and run oil through that loop. You're going to hear the pump do a little snarling and knocking, and you're going to clear. There's going to be remaining air in the filter. There's going to be air in the pump. There's going to be air through the rest of the system. You're going to pull that lever and let it circulate. And what's a compensator do? Nothing at this point. You pulled that lever, pressure dropped, compensator went offline, tink, pump goes full stroke. There's a spring in all of these that puts it to full stroke. It's pumping away. You're not going too fast. You're not really hammering on it. You're just running flow through. Now at this point, flow is controlled completely by RPM. So if you had a flow rater on there, you could even find out what your new pump's flowing if you wanted. You said, why don't you do that? Well, it's a new pump. You shouldn't have to, right? Parts man ordered the right pump. So, and you're going to compare it externally. Be sure it's the right one. Now, after about half a minute, 15 seconds to 30 seconds, which is a longer time than you think it is. Excuse me. Now, if you can, on the pressure side, not many of these you can, what you're going to do is switch remotes. You say, what do you mean? You're going to shut the one off with the loop hose in it. And you did loop it both directions just to make sure you got all the air out of that, at least that one circuit. Now you're going to go to the other one and pull the lever and check your main pressure. 11 or 1200 is enough to give you a good solid pressure. You say, well, usually RPM on open center systems, yes. On closed center, it's not so critical, your RPM. True story. So what are you going to do? If your pump's quiet, you're going to pull the lever and see what your pressure is. Now, you fired the thing up, you held it over. One of the things you're going to do, and I've had to do it, test some of this by myself, but you pulled the lever, you got your pressure, and the pump should have gone back near neutral. But if you hear the pump sounding funny still, that means you knocked the relief. What are you going to do? You're going to go back, take that compensator and loosen it, quarter to a half a turn, go back and read your pressure. Now on these things, if you want to tie the lever back, it doesn't hurt it. It's not an open center system. Okay? So the relief isn't popping all the time if it's set properly. You're going to just tie your lever back or block it back and check your pressure. You're going to, if you can run a hose around so you can hang on to it, you're going to back your compensator off until the pressure stops. And it'll go down. as you turn that compensator out, it'll go down. And then turn it back up until you see your needle all of a sudden kind of stop and you hear a little hissing noise. Well, read the gauge. You'll know your cracking pressure of your relief valve because you'll hear it. So say it's 2800. You're going to back this off to 2400. Yeah, that's more than 300, isn't it? That's correct. 500 is better. But right back to about 2400. That way you've got your 400 to 500 psi. Nice. 300 is good. So if you take it and you check your system and you're at 300 and that's where things seem to be better, then leave it. But because on a tractor, it's not quite so critical. Excavators and such, now you can get into more trouble. But still, you've got your set. But what else can you do while you're here? Mark it. There's another one you're going to do that's quite interesting. Now, you've had your pump running, right? Back the compensator off. You're looking at your gauge. And the gauge will go, drop down. And I'll go down below 1500, about 1300 psi, and let it sit there for a second. And because it'll come back and stop, but it can go all the way down. Sometimes it'll stop at whatever the priority setting is. Yeah, it'll shut the auxiliaries and everything else off in your pressure priority valve. So once you're there, you back it off a little more, turn it back up until you just see the needle, because you'll be able to turn about a quarter. You've gone far enough, a quarter turn at least. Bring it back up until you see the needle start to move. Now you know roughly where your priority is. Well, priority on these, if I remember right, is somewhere around 1400 to 1600, 1450, 1650, but 1500 is a good mid place. That means there's 1500 minimum pressure for your steering and your brakes, which is also connected in with the PTO system. But you have your pressure for brakes and steering right there at that point, or up to that point completely. Okay, that's the priorities part of it. After 1500 psi, now it clicks and you start to raise your pressure up in your remotes again. Because now the priority valve is shifted. There's enough pressure to run the brakes and the steering. Are you going to be exact? Yeah, you'll be right there. Excuse me, you might be 50 psi off a little bit, but what are you doing? All you're doing is confirming that you changed the pump. Now you got to check the rest of the system, and hopefully you've taken that valve off and cleaned it all up, because the pump did go bad. Because the pump goes bad, it goes through the system. The filter's before the pump, not after. So you've got your block cleaned, you're doing your adjustments. Now you got your priority. Well, while you have your priority, check your brake and PTO pressure. I don't remember what it is on these things. They can be anywhere between 150 and 200 and some 250, 300 psi on some of the tractors. Don't remember. Look the book. So now you turn it back up until you hear a squeak of your relief valve again, because you're still operating your system. Now confirm it. Back it off. 400 psi. Lock it. Or mark it, one or the other, but it's good to lock it there if you can. You're pretty well set now. It's done. Why? Your priority valve's working. You've tested. You can go back to your PTO and test your minimum pressure there, your low pressure system, and that'll give you an idea that that's functioning. You've got your priority, your unloader, and your low pressure checked, and you checked your relief, and then set your compensator. You're pretty well done. Now, the other part too, though, is when you take that control valve out, on the early 55 series, they had a funky compression fitting on that valve body. I mean, weird. It had a huge, I think it was 1 5/16" nut. Now, I had an Armstrong wrench that I had filed down to somewhere, ground down between, 5/16 and 3/8 of an inch. It would just slide in there beautifully, because there's lines and other stuff that's in the way, and then you can take that thing out of there. What do the others have? They don't have a special hose like that one. Both ends are JIC, because that's the pressure input hose. It goes into the back corner of the valve, in towards the transmission housing. Transaxle for some of you. And but the one for the early ones has that big, huge nut. And it's as simple as that. You just have a nice thin, I think, 1 5/16" wrench. I might be wrong on that, but I'm pretty sure that's what it was. And because I had a special wrench where, for certain things on Alice 6000 series, it had the 1 5/16" thinned down on one end for the 55 to or early 55 series, and then the other end was I ground 1 1/4" out to 1 3/6. What was it? 1 1/8" to 1 3/16", cut it off and turned it, so I had an angle wrench, so I could take some of the 6000 series tractors apart up under the deck. Those Armstrong wrenches are tough. So I don't even know where mine is. I lost it years ago. I haven't needed it, so didn't care. And that way you can get that fitting out, and you'd have to replace the entire valve assembly to be able to put a JIC in there. But just food for thought. Anyway, that's your basic system. Now there's a similar setup on the large frame tractors that have the charge pump on them, the 2135s, 2155s, and similar. The large frame has that huge PTO cover on the back, not just that little one like the 55 series does. And yeah, I call it the large frame, big frame, heavy frame, big block. So they have a charge pump, but the pump itself and its valve operates almost identical. So just something to keep in mind when you're troubleshooting with these things. Anyway, that's an overview of that closed center pressure compensated system. It's actually simple, very simple. It's nice. They work smooth. Oh. Now, one last thing before I go. You're coming out and you're hearing noises. You turn the steering wheel, it's noisy. You run the 3-point hitch, it's noisy. You know, on the auxiliary hydraulics with the hay bind, it's not quite so bad, but it's noisy. Well, what do? You want a JIC number 6, I believe it is at this point. You take the line off the case drain, housing in the back, suction line in, pressure out, suction in, pressure out, and on top is a little elbow. It goes to a little metal hose, it goes, or line, it goes back into the reservoir. Well, it goes direct into a little port in the reservoir on the small frame tractors. And large frame tractors, I can't remember if it went into the suction side or down into the gear case, but either way, it's something simple. Almost, you don't want any pressure in the case, you know, maybe a few pounds, 10, 15, 20, but not much. But anyway, you take that line off, pop it off, turn the elbow if you have to, put a plug in it, and you haven't capped this yet, have you, on the elbow? Don't. Either put another line on or jam a rubber hose over the end of it and put it in a bucket. Maybe. Then have somebody fire it up and see what comes out. It should come out a nice flowing stream. Look just like you started squeezing Dawn dish soap out of the bottle. When they're bad, I didn't have a hose one time and I had a guy fire up the tractor. Steel line up out of the way. He fired it up. Oil shot past the front of the tractor so fast, he shut it off and looked at me and said, "Oh, I guess our pump's bad, huh?" Real bad. So they will have a flow rate in the system. You get a nice big old beaker so you can measure it. And the only thing you're going to be able to do is have 2 buckets, especially if you're there by yourself. But you can be up in the cab with a bucket and your beaker, fire the tractor up. Then when it starts coming into the beaker, start your stopwatch. Then it'll tell you how much to flow and what kind of time period. Usually a minute, 30 seconds, something like that. Find out how much is in the beaker when at the end. Don't shut it off. Now this is a funny one. Don't shut it off. When you get near your time, pick the hose up and drop it in another bucket. Don't try and put your thumb over the end of it. That could be a mistake. But you could try it. Either way, you just pick it up and put it in the other bucket. Now shut it off. And that will give you an idea of what your actual, in other words, the beaker in the bucket You got it near the rim, and when time comes, you just drop it. And then you'll have so much. And that'll give you an idea of the condition of the pump. But you have to be careful, because if that sucker sprays out of there. But noise alone will tell you a lot. But don't trust any of that until you put a good filter in there. Check the filter before you change your pump. And when you get a new pump, put a new filter in. So those are the things that can give you some ideas of how they operate. Now, last one that I ran into accidentally. They never taught me this at the Oliver White dealer, especially on the small frames. You got a hay bind and you start to drop the unit, and it goes junk, 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 junk. I mean, violently sometimes. The idea there is that because it's a pressure compensated system, they have a flow control on the individual valves on almost all the White tractors in 1855, 1955, maybe even the 17. And it means that somebody's restricted it down so that when it lowers, there's not enough oil coming out, and it'll actually cavitate, jump and stop, jump and stop. There's something to keep in mind. You have to turn the flow rate up, not down. Now, it can go down too fast, and you may find that you do need to adjust it. But the basic principle behind this is you should have a flow control out on your cylinder itself. Might be one of those one-way check valve things, where one way it's an open check and the other way is a restrictor. Well, why would you do that? Well, you set your restrictor so there's a little bit of back pressure in the cylinder. That way it can't be jumpy. So maybe going up, there's no problem, so have nothing restricted. Going down, you want to have a little bit of restriction in the head end as it comes down. So if there's a little pressure there, it can't do the chatter thing. So those are two ways to fix your chatter. I had to have a case guy tell me that one. Anyway, you folks have a good night, and catch you later. 27 minutes, 12 seconds. Peace out.